Good morning, everyone. My name is Dave Martin, and I'm the CTO for a company called Blackfoot. What you're going to see here is something very different than you've seen before. It's not a technology conversation per se, and there's no pretty pictures. What I'm here to talk about is why does a small service provider care about all of the hard work you guys are doing? Believe it or not, well, you may know this, there's over 1,000 small service providers in the United States alone. They represent millions and millions of customers. When you expand that to the rest of the world, it's orders of magnitude greater than that. All of the work you're doing is going to contribute to the future of their environment, of our environment. I've been coming to these conferences for 4 years now, and I will tell you honestly, it's been somewhat disappointing because anytime the tier 3 and smaller, and these are smaller, anytime they're talked about in terms of they're never going to adopt it because it's too complex, it's too difficult. I would argue actually that our environment, we're surprisingly innovative. As an example, our company in 2001 began the conversion of all of our services and network to pure IP. By 2005, 100% of all of our traffic was either SIP or MGCP, and all of our network was Ethernet. We have different resources and different planning horizons. So when we can't go out and spend $1 million to initiate a POC on some new technology. We rely on the hard work everybody else does and then try to consume it to the best we can. But we have to plan for skills development. We have to plan for, we're extraordinarily sensitive to depreciation cycles, federal funding, things like that. But it doesn't mean we're not innovative. We just need to work with these groups early on to figure out how to best consume and contribute to the work you're doing. So, on to the next. If I hit 7.5 minutes, throw a rock at me or something and let me know, because I can tend to just ramble on. So what are we doing at Blackfoot, at any rate? So by the end of this year, possibly the beginning of next, we will have deployed a Seba environment in a test environment that incorporates all of our legacy equipment. And so what that means to us is our current model of obviously routing, but also our DSLAMs, our soft switch environment. Everything will be remodeled or modeled in this test environment, and then we'll begin to learn what skills are necessary, but how are we going to integrate the components? We can't afford to go out and just wholesale change everything out, right? We're going to have to go out and begin to introduce the components in a controlled fashion so that we can control all of our expenses, but still introduce new services. You know, and that's the other thing is that we have finite revenues. Most of the population of these small service providers are very tiny towns. I mean, 500 people. A big town would have 1,500 to 2,500 people. An extraordinarily large town might have 10,000. But they have hospitals. They have really serious need for remote medical services. They have banks that are parts of large chains. We provide services to a bank with 100 branches. And so, the networking requirements and the service requirements are every bit as demanding as what the Tier 1 service providers provide for. They're just kind of smaller in size, if you will. So, we've launched an open source API gateway. We actually are moving all of our back office systems to microservices and away from large legacy, one size fits all, if you will, end-to-end kind of thing. We've begun the introduction of an abstract layer on top of all systems so we can create gateways into the microservices, if you will, and we'll obviously use that API environment to communicate up and down the service delivery chain. And so, how we'll use it, everything I just said. But as a training environment and to understand exactly how to integrate. And just as important, to talk to other telcos, to talk to regulators who give us money, to demonstrate that we're actually making good use of their dollars that they give us. Small rural service providers are extraordinarily dependent on that. Many of them, over 50% of their revenue comes from the federal government. In our case, we've done a lot of work on for-profit subsidiaries. We're down to roughly 20%. But still, you have, we don't want the feds to go and say, you guys just waste all of our money, we're not going to give you any more. So we need to continue to look ahead. We keep a sliding 10-year technology vision so we can understand where we'll be and what it's going to take to get there. What kind of skills do we have to develop? What kind of infrastructure do we have to begin to deploy? The other thing is we're very active in our rural associations that represent the 1,000, if you will. So we're introducing these concepts. We've been working with ONF to begin to get ONF to come in and give presentations to be able to talk to that community. Yeah, and then we'll bring in, we've done this before. We did this with conversion of our networks to pure IP. We brought in people from the FCC. We brought in other telcos to show them demonstration areas. And we're going to do the same thing with the Seba environment. We expect that to expand into Volta pretty rapidly. We'll begin to integrate across horizontally, if you will. And I think that's about all I can say about it. All right. Thank you.
I think it's number one. Yeah. Okay. Okay. Thank you. So in the previous session, I shared with you the update on ODTM project. But okay. I think it's not my bad.
I got that. Yeah.
But anyway, in this session, I would like to give you a quick update on NTT Group's activity in ONF as a whole. So it includes not only the activities in ODTM project, but also the activities in Seba and PON Project. So from this session, you can give a brief idea about how NTT is doing, what NTT is doing in this project, and how we use the project in our network. So first of all, let me quickly review the ODTN project, how we expect the project in our network. So first of all, we expect the future transport network to be, from two aspects. The first of all is the environment, multi-environment. So we expect the transport network in the future will be made up of multi-layer, multi-domain, and multi-vendor. So that's what I discussed in the previous session. And also from the function perspective, we expect that all the function in the future will be dynamic. We expect dynamic resource management, dynamic bandwidth management, and dynamic routing. So by taking the advantage of two aspects, we expect that in the future, the network can benefit from shorter lead time, optimizing network quality, and simplified operation. So that's our expectation on the transport network. This picture shows a rough overview about the current status in our network. A few years ago, we used a totally vendor solution in our transport network. You can see from this picture, the device is made by one vendor. The controller is also made by one vendor. So it's vertically locked by a single vendor. And also, from the interface perspective, we use legacy interface such as the TL1, CLI, and SMP, and so on. So this is the situation in the past. But now, one progress we have made is that we realized one controller to manage a different domain and different vendor. So to some kind of meaning, so we implement a multi-vendor environment. So you can see in the middle, the current status, we have one unified SDN controller to manage a different vendor solution. But you should note that the current status is that the controller is still a vendor solution. So we use a solution from one vendor. But what we have improved is the application lead time. So in the past, we were spent more than half a year and even 1 year to add new functions into the system. But now, we try to develop the applications by our own. So in this way, we achieve, around 3 months to add new functions inside our company. We utilize the SDN platform, controller platform, and add new functions on that. And in the future, so we expect that, first of all, from the device level, we expect, disaggregated device, which I discussed in the previous session. And also, we have a goal to introduce open source solution. So ONS could be one of the promising candidates here. So in order to get rid of the vendor-specific solutions in this area. And also, we would like to continue to develop our own applications on the open source SDN platform in order to even shorten the lead time of application development. So that's the status of the optical transport layer. So let's change the topics a little bit. I would like to give you an update on our activities in P4, Stratum, and PON Project. So actually, for this project, our group company, NTT East, together with the NTT laboratories, is now actively investigating the use cases for such kind of solutions. So mainly we focus on 2 aspects for this new technology. The first of all is to reduce cost, while we try to seeking for new application, new revenue increase by utilizing value-added service. So when talking about cost reduction, many people will say that virtualization will help reduce cost. But unfortunately, if we use a core server, we find out that in order to get enough performance, in order to get enough throughput, we have to deploy a lot of services instead. So which actually, as a result, is not cost effective. So we try to. I will discuss in the next slide, try to use the P4 and deep plan programmability to offload some kind of hard functions into the hardware in order to reduce the cost here. And also the value-added service. Some kind of new service like video streaming services requires the extremely low latency. So that is also another motivation that we tries to offload some functions into the hardware in order to get the better performance. So this slide shows a very typical use cases that we are discussing internally in the company. So it's the video streaming use cases. You can see on the left is the current architecture that we use for video streaming. So you can see that video data will be collected from one branch, then sent to a centralized streaming server in the centralized cloud or data center, whenever it is. Then we do some video process, like decoding, encoding in the server, and finally do the multicast to the end user. But we found out that this is not a good way from two aspects. First of all, the latency. So we send traffic from end user to the cloud and send back to the end user, so which brings lots of latencies here. And also, because we use the transport network here, which utilize actually lots of bandwidth of the transport network. So in order to solve such issues, we try to investigate a new approach based on P4 and P4 technology. So we try to deploy programmable ASIC hardware on the edge, as shown on the right picture. So this programmable ASIC enables some kind of streaming protocol handling. So we do it. We offload this function into the hardware. So in order to improve the latency and decrease the network bandwidth in the transport network. So this is one use case. Another use case is the offloading BNG functions into the programmable switches. I think many people here discussed about BNG offloading. Actually, we are thinking about the same use cases in our production network, and mainly for two reasons. So the first of all is to reduce the cost. If we use the court server, we think that it may require more server, which will be not cost effective. So that's why we try to use the programmable P4 switch to handle such case in order to reduce cost. Another aspect is that we are thinking of adding some new services, not as a VM format, but offloaded to the hardware in order to provide value-added services to the end customer. Last but not least is our activities in the Seba project. So actually, NTT Lab is proposing a new technology which we call it's a mini PON. So what mini PON it is? So as shown on the right part of the picture, so mini PON actually is based on a concept of module type pluggable OLT. So why we need that pluggable OLT? It's because that we have different kinds of deployment scenario, like FTTH or the fiber connection that provide to the enterprise user. Different type of connection may require different, may have different requirement. So that's why we try to use a changeable OLT module that in order to fit different needs for different scenario. And also, some of the OIT function here, we expect that we can implement it in software way. So such as the function of DBA or PON OAM. So if we implement it in a software format, so we can easily switch over from one module to another module in order to fit the different requirements of different use cases. So the reason we joined Seba is that we think the Seba activity, such as the VOSAR, could be a very good candidate for the management plan and C plan. So we actually joined this project and contribute to the project to add the functions so that the current ONS could be used to control the mini PON architecture in order for us for our future deployment usage. So that's all for my update. So this session quickly update our activities as a whole, NTT Group in the ONF community. Thank you.
So hello again. Just want to make sure everyone can hear me out there. It's working correct? Okay, good. All right. So I want to talk to you a little bit about what we're doing with OMAC at Sprint. Now, if you were at ONF Connect, you'll know that I brought up during a keynote that Sprint was actually looking at deploying OMAC in a field trial in 2019 at the edge. And what we were looking for was essentially edge applications, because obviously it doesn't make a whole lot of sense to deploy at the edge without an app. And by the way, that's still out there. We're always looking for edge applications, interesting applications. We've seen some use cases today with some folks that are actually deploying as well. But I want to get a little bit more into the specifics. So just a recap, right, on OMAC, right? So we are trying to get that production grade. And suffice it to say that we're investing millions in order to do this, in its development and its testing, and we've been doing this a long time. So we're ramping up our development in order to get it over the finish line with this. The OMAC functions, as we've talked about, are, right, several different projects, but specifically for the edge, we're interested in the billing side of this, so the trigger function, the CDR router, and essentially the NGIC components, which is the separated control and user plane. So we're essentially pushing those functions ahead of schedule, right, and we're essentially testing those as if they're going to go like any other network element into production. So we've talked also a little bit about this in terms of what we're after. Now you'll notice here that we have a kind of a reduced set of what we're after. We are looking for basic MME support in the controllers, the control plane, but we're obviously not using the open MME in this case. We're actually hooking up to our production MME and all of our production ENOBs and femtos. So we have probably, and I would say independent of any specific multiple versions of vendors, right? We typically have more than 3 vendors, and if we look at the life cycle of all the different versions we run through, so we'll probably be running several dozen different variations of eNodeBs, and probably at least 2 to 3 major variants of MMEs coming through. We're heavily LTE option 3X focused as well, so we're looking at our new NR deployments. And then based upon testing, because we do still have CDMA and other items, we'll figure out how far backwards we go into the 3G space. But we're primarily focused on edge, and right now, right, we kind of look at that as being more forward-looking with 4G, 5G. There's a lot of realities, though, that come into the code. So there's what you test and what you build as a development organization or as an R&D organization. And then there's the reality of trying to convince an operations director in a large network, as well as a regional vice president that's responsible for the customer experience, to even trial something. So obviously our criteria gets far more stringent as we get closer to production. So this is a list of the things that we're pushing in terms of that next level of detail. So we talked about OAM. There, we're doing full compliance with 3GPP. We also have a common secured command line interface. If you're familiar with the US standards, right, we're focused on things like FIPS and those sort of items that you would kind of consider your usual suspects. The VM deployments, once again for now, just because we have other projects in looking at containers, other items, I always think about having kind of a low sort of bar. We're asking our friends downstream in our organizations to do a lot by taking on this type of code in a field trial. So we try not to actually add on complexity by introducing 4 or 5 or 6 or 7 or 8 more new technologies for them to try and digest. We really want to be a smooth transition, and like everything we do at Sprint, we prioritize the customer experience. So we want to make sure everything goes as smoothly as possible. So we're really isolating this. One note about user plane copying and lawful intercept, and I've brought this up if you're attending the TST meetings in OMAC or other items. There are very specific regulations. So if you're familiar with the way LI goes, you have to have it for production. 3GPP defines what they refer to as the base parameter. So you get about 98% of your functionality. But then there's something referred to as national parameters or local or regional government requirements. Those can't be open sourced. So that's, at least at Sprint, we're going ahead and developing those national parameters because we are pushing this into production, but you're not going to see that out in the code. That's just, the way we would expect all the regional parameters to work. So the way to think of OMAC is we can get you about 98% of the way, and then, right, you've got some regional requirements that you have to think about in terms of getting it to that final last step. And, we can talk if someone wants to ask offline that's in the same regional restrictions we are, or regional requirements we are, we can talk offline about kind of that code and that development. The production readiness is the piece that always scares a lot of people, especially if you're talking about telcos, right? We've been around for over a century. And we have a lot of people who, it's not that they're resistant to change, they're resistant to anything that may negatively impact the customer experience. So we've been beefing up a lot of our front-end processes. And I'm happy to say that most of our stacks now, the structural side of that, are actually generated from the Word documents of the specs themselves. And these Word documents have been corrected. So if you watch Sprint's actual work in the standards, we are actually correcting the documents so that we don't have to have a lot of handcrafting, hand coding of the stacks. And what that does is that allows us to very quickly update in a matter of minutes, average turnaround time in some cases. I would say diameter is about 90 minutes. A new GTP spec, right, we can roll through it in probably about 6 minutes and then generate the new code, detect the deltas, and kind of move forward. So we're getting to the point that we can actually get very efficient with these updates and become, I don't want to say agile because that might imply 3GPP or IETF's agile. I don't know that I want to go that far. But we're getting more efficient with this. So we have had full scans with Black Duck, a lot of Synopsys tools, and we want to thank them. They've been very helpful in a lot of our work. And that's happened at multiple companies. And so I also want to point out the code you look at out there has been scanned for security issues, has been scanned for license compliance. No scan system's perfect, but it's above and beyond your usual run-of-the-mill, does it have this license header? So we're running to that. And then right at this point, we have, I would love to say, as a director, that we're only running 1, 2, 3 tools. I really feel like at this point, we're running 3 to 5 different test tools in order to get the system out. And I think my team keeps finding new test tools to try out along with this. So we're loading up, unfortunately, on the code. So this is kind of the reality of the code in terms of what's happening for us at Sprint. And then the real question is timing for you guys. It's one thing to see, right, and to talk about it. It's another thing to see it in the repo. So there's the code that's been released, which is the scan code base. That's really more of the July code base with some major features and fixes from our friends at Intel. And that has those scans we talked about with a lot of the Synopsys tools. We're also updating specs. So you'll see as we kind of go through the year, weird things happen. You'll see us make CRs and then submit bugs back to the open code and then run it through. Or you'll actually see us submit fixes first in the code and then backdate the CRs. So it's going to be an interesting situation. We will be running ahead in the code of the actual standards. So testing, once the codes arrive, and actually we got the first drop last Friday. So I'm happy to say it arrived in 1Q, but I don't know if we want to round up, so I call it 2Q. But basically, we've started the acceptance testing on our side from all of our different suppliers and our internal teams. But we are, like I said, readying this for production. So this means that we measure this stuff, even though we're very quick, we measure this in terms of weeks and months, because we, for instance, have a 2-week soak test just to make sure that accounting's coming the way we want. So this will be done. We believe the earliest finish for the base code, the majority of these changes will arrive in 3Q. And so you'll see that then propagate out on the OMAC side. It will be a very specific branch. We haven't figured out the name or worked with the TST to actually figure out exactly all the logistics. But you'll see announcements and other items coming out on any sort of associated mailing list or out on the repos in terms of that. So That's also, once we have released that, right, we'll start the process of getting out into the edge trials as well. And I'm looking forward to hopefully getting some really great results in terms of the field and everything else here in 2019. So that's it for Sprint. Thanks.
Hello, hi everyone. This is Bora Eliciak from Netsia, and today I'm going to talk you about Türk Telekom's involvement in the ONF projects. Our involvement with ONF, it actually goes back more than 5 years ago when we first started with the ONS, M-Cord and A-Cord. But nowadays, we are now focused on Seba, and we are heavily investing in Seba. As well as, of course, as a natural roadmap to Seba, we are really focused on COMAC as well. So, but you may ask why Seba and why COMAC is, within our interest. So the reason behind is the Türk Telekom transformation journey. And we have actually started this journey a few years ago. And we took a multi-step approach to that. So first we have started with analyzing the network, looking into the tiny details of the network and the services and the architectures that we have in place. And then as a second step, we have identified the best areas that will make the most sense for transformation. And then as a next step is the preparation of the infrastructure, bread and butter, and then the architecture, the overall network architecture that we're going to head toward. And finally, once you have everything in place, you will have to manage that in a centralized and automated way. So having said that, here is the high-level architecture of the Türk Telekom transformation. This is the big picture where we envision the devices, end-user devices, and the access networks on the left-hand side that would all get connected to an edge cloud, all through sharing the single same passive optic network, and to end up on a shared cloud infrastructure that is actually formed of a base platform and several different use cases. To do what? To actually reach at the back end of the network to several different services in a seamless, ubiquitous manner that actually you will, reach IPTV, voice over IP, HSI, or any other IoT or business services that you might have. And we have actually started building this more than a year ago. And we demonstrated this back in September in the Mobile World Congress Americas in LA and in Istanbul in our 5G conference. So the roadmap actually to achieve that big picture, as I said, has already started. And the first step forward will be the hardening Seba. And we are working on our own distro that is also be productized, and we will add some features that actually that would address the specific needs of Türk Telekom, and then integration with ONF to achieve the centralized orchestration, and integration with OSS, and so on and so on. And as I said, we have come up with identifying the use cases that would make the most sense. And one of them was Seba, obviously, and the second one was G-Island. So these are the two things we will be actually delivering to the field first. And Seba, for Seba, we will have a large-scale field trial Q3 this year. And, but the real action, the real deployment will take place in 2020. And of course, Seba and G-Island will be followed by our VRAN project, where we have where we are introducing the mobility, the mobile network into the picture. So, as you might guess, what we will end up with will be a multi-access, multi-service edge cloud, which in turn will be supporting a joint profile slicing, which I'm going to touch in a minute. And it will be integrated with a global orchestration, and our choice of global orchestrator is ONF. And this whole thing, this whole infrastructure and software and the platform will be based on open source and open platforms like white boxes and so on. And after seeing Larry's presentation just half an hour ago, you might guess that, oh, this sounds like COMAC. When we first heard of COMAC, we really got excited, and we also get involved in COMAC, and we are supporting it. And the platform will actually come as a COMAC distro. So this is what we are preparing. So when I say multi-network, actually I mean the mobile network, fixed network, the Wi-Fi network, or an IoT network in a generic sense. You can add more networks, but this is going to be the the initial context of it. And when I say multi-service, it's going to be any service though, but we'll start with the high-speed internet, voice over IP, IPTV, and IoT services. As I said, our secret sauce though, maybe I can say, will be the slicing. We are working on, and it is it's a pending patent, on a joint profile-based slicing, where you will just need to define a generic slice definition, and the platform will actually convert it into underlying specifics, underlying technology specifics, so that it will give you an end-to-end ensured slice, whether it's on the radio or whether it's on the PON network or on the cloud. So yeah, with that, that's all I have to say, and I want to hand over to Tom. Thank you for listening.
I'll go ahead and say hi. I'm Tom Anschutz. I'm from AT&T, and I have the unenviable competition between my talk and your grumbling stomachs. So, and mine too, for that matter. So let's try to make this as interesting as possible so that you forget the fact that you're very hungry. All right, today's topic is our interest from AT&T in ONF projects. And so, well, let me actually pause for a minute. How many people have heard me talk before? Oh, wow, okay. So, I should say, for you guys that have heard me talk before, you're going to hear the same thing again. That ultimately, I'm talking about, the most important thing for me is how the telcos need to transform and build community and work together. And if that's already in your heart and soul, you can go eat now. You don't need to see the rest of my time. All right. If not, then I've got a few words for you. So, I'm also not going to go into depth in Seba because my colleague Tom Moore talked about the Seba project this morning, and you should all know that that is really near and dear to our hearts. We have field trials for Seba going on at AT&T right now, and we're moving forward very aggressively in that space. All right, now see if it clicks. All right, that works. So why don't we start off with, I always like to start off with what possessed us to do all this stuff. And it starts here with a big picture that a lot of people put the buzzword disaggregation around. And if you think about it, in the old days, and you've heard me say this, I'm sure, there used to be these vertically integrated boxes, and they were all quite different from one purpose to the other and from one vendor to the other, all the way from their basic operating system to their feature functions and to their element management and capabilities. In the new world, we can imagine open hardware, and in fact, this picture you can read for yourself shows some examples of where AT&T and other companies have released specs, open specs, right down to schematics and bills of material and so forth for these types of hardware. And the good thing, why would you do that, right? Why would you do that when there was a perfectly fine box already? And it actually comes back down to OpEx. It comes down to, if I specify these boxes, I can actually specify their very low-level BMC capability, the way that you load firmware onto them, the way that the operational interfaces go up into my OSS BSS. And so even though there might be lots of boxes from lots of vendors that do many things, a lot of the things that I do as a carrier wind up being able to converge. So I have a common onboarding, and all of this is really pretty much shamelessly stolen from IT folks who've known how to do this for years, right? They bring in a server and they have a BMC. They understand how to load firmware on many different kinds of servers and OSs on them. And then they go into a pool and they're orchestrated. And we're trying to pull the same thing off for the network hardware that isn't servers. We already got the servers. Now let's make the other things work the same. And well, okay, so we got as far as making these white boxes. We put in BMCs. We've got ONI to load a firmware and so forth. But now you want them to do something, and guess what? The hardware manufacturers for these boxes don't actually make all of those wonderful routers and switches and gateways and load balancers and all those other things that we actually need these boxes to do at the end of the day. So it has to go, these things need to go hand in hand with the big picture of software, right? So this is part of the disaggregation. I have white boxes, and I'd like to be able to upgrade, like say GPON to XGS PON or to a 25 gig PON. But guess what? All those features and functions and all of the things that they expose to our management systems, I didn't really want them to change. I just want the PON to go faster, right? So if I can keep my software, my open source software, more or less static, and I can change out the white boxes underneath that so that I get the next generation of access technology, or I get the next vendor who has given me a better deal on hardware, then it is an OpEx wonder, because I don't have to go back to my IT organization, who's sitting right in the front row and smiling at me, and ask them, I need you to integrate a new EMS, and I need you to sort of figure out how the management flow in this new box works. None of that changed. Only the merchant silicon at a very low level changed, and probably a little driver, but all of the things that actually turn that silicon into an access node or into a broadband network gateway, that didn't have to change when I moved from one to the next. And all right, so that's the game I'm playing, right? How do you get that done? Well, there's not too many places. And so here's when I'm coming back to why are we interested in ONF. In the entire world, there's only two places that I know that do this kind of disaggregated system architecture, and that's ONF and TIP. So here we are, right? And TIP is doing great work too. I do a shout out to them, right? But we've gotten involved early on with the ONF, and we're really pleased with what we're doing there. It's not only about ONF. As you can see from the chart, we have some big bets on other Linux Foundation software that we think complements the sort of the disaggregation. You need to have the large-scale orchestration like you would get from an ONAP. And back to the operations, we have a desire to be able to cookie cutter our deployment of tiny little edge clouds. If you've got 5,000 central offices like AT&T and you want to put a cloud in every one of them, one, it better not be very expensive because there's only so much capital in the world. And two, it can't be labor intensive. So to the extent that we can use something like a Crano to have a basic, it's a cookie cutter approach. We put a preloaded rack into a central office. Crano brings it all the way up to the point where Helm charts are ready to go in the Kubernetes environment, and from there, Seba can take off, and the other things I'll talk about in a moment can take off from there with the centralized orchestration from ONAP. Okay, this clicker's just taunting me. All right, so one of the things about community and what I was trying to bring across, one of my foundational points for speaking, is that community is not about telling other people what they should do. Open source is not about telling other people what you want them to give you. It really is, you've got to get skin in the game. You have to have people who are engaged in the process. And here I've got a list of all the different, well, first I got the pretty picture because you guys, you need something entertaining. But I've also got the list of how we have engaged. We have an organization within AT&T called the Foundry, which kind of plays fast and loose with all the corporate rules, and they get things done very quickly. And then we have the access team, which is not the fast and loose. These are people who have the P&L responsibility for rolling out commercial things at AT&T, the ones who are very serious when you talk to them about the next generation of technology. And so we've pulled them in. We got the foundries to help us with the Foundry people to help us with the agile development and understanding how these things work, sort of the explorers, if you will. And then, we've got the access team, intimately involved. You heard Tom Moore speak this morning. He's in that team, working these problems and probably getting gray hairs along the way. So we are engaged, and we're engaged deeply in this, and I think that's one of the important things. If you're interested in the same sorts of kinds of benefits that I think come from disaggregation, and from sort of owning your own business or destiny, then this is the way to do it. All right, so you should realize, you just saw Larry talk about all of the reference designs that are going on at ONF, and my boss didn't want me to show things that hadn't been agreed, so my chart looks a little different than his. So there's no MAEC, because that's not an RD at this point. It's sort of an idea. And the actual overlap and where we will reuse components among these RDs that are in existence is not really well defined yet. It's still being negotiated. So I'm playing a little stricter with the rules here. Sorry, Larry, wherever you are, probably one of us owes the other a beer. Maybe we just both have one. All right, so these are, the reference designs aren't just sort of something that, well, I'm going to pick on Larry some more because I'm on a roll. They're not just something that ONF is allowed to come and say, hey, we like this, you should do it. A reference design is part of a new concept at ONF where you need to have multiple carriers who are interested in that technology and are willing to bring it to production. And so it's not just demoware, it's not just an experiment or a science project. All of these reference designs are intended to support carrier members of ONF who want to use it in a production sense. And so, gosh, I think out of the things here, Seba and Trellis, right? You've heard Bora talk about Seba. AT&T's clearly interested in Seba. Trellis has been deployed by Comcast, and it's very interesting in a lot of ways. COMAC is on the drawing board. No one has done it yet. Okay, it's an agreed reference design, but it hasn't been finished. And ORAN, there's been a lot of, I'm sure you've heard the announcements or will hear them before the end of this week. There are open source communities in ORAN to help open the RAN part of 5G. Okay, we're interested in all these areas. We intend to not just do this in one place. For example, ORAN is a Linux Foundation activity, and we really want them to work well with the ONF, like they've done in many other areas. Okay. Oh, I didn't expect the build. All right. So for us, what are the next steps with all of these things? For Seba, it's commercialization and deployment. I won't belabor it. You heard Bora speak about, we think that there's hardening that needs to happen. We, AT&T, would like to see some system integration occur and have a more traditional, let's say, supply chain model around the open source than some others. And we're eager to get that deployed. Gateway functions. The Seba that exists today doesn't have the broadband network gateway. And you know what, I don't know if we should create a broadband network gateway as a standalone item or just run to a converged gateway that works for wireless and wireline. And I think with the ability of disaggregation and using open source, that common infrastructure can support both of those tasks at the same time. If you follow that thought, there's some really interesting convergence ideas behind it. AT&T is working right now at OCP on a 25 gig PON based on FPGA. And so that's something that we're interested, we're getting the first prototypes into our labs, and they're looking really good, and we're interested in moving that ball forward. So wireline, you know, all the promises you've heard about 5G replacing wireline, well, being the old wireline guy, I'm going to tell you the wireline isn't dead yet. Right? You think, look forward to your 25 gig, all right, or your 25 gig internet access and see if your phone will do that. Pivot to cloud control, right? We've interested in having ONAP and our other large-scale orchestrations not just control VNFs, but control cloud-based or CNFs. That's going to be a big topic you'll hear a lot this week, but it's one that we're very interested in. When you move to the edge, there's not so much space to completely replicate an OS for every function that comes along. So containerization is really important, and eventually when third parties come, we probably will have to go beyond that to unit kernels or snaps or other things that'll allow you to mix and match kernels in a small container-like environment. So these are all cool things, and that might turn into something fun for Larry to do in MAEC. I've hinted a few times, but wireless wireline convergence, and Bora practically stole it from me. But well done. Whoa. It's okay, I can still keep talking. Nothing will stop me. So wireless wireline convergence is something we're really interested in. When the things that turn merchant silicon into a personality, either a wireless personality or a wireline personality, a broadband network gateway or an SAE gateway, when that's all in software, you can imagine a first step where you've got common hardware infrastructure that supports both of these. You already have probably your product folks telling you they want the same apps available regardless of whether someone's wireless or wireline. The GI LAN from Bora is a no-brainer, right? You want this sort of space behind your access network, regardless of what the access is, available to provide any kind of service you've got. And so convergence plays out in a really, I think, an interesting way from sort of ground up rather than from large standards down. And I think that is very nearly the end. I told you what was the end or the upshot or the punchline for my talk. It is really, we think, the most important thing is community. That carriers have really to transform themselves to think more about using things and composing things in a cloud way, finding ways to employ and deploy DevOps within your company to gain speed and agility, and sort of move the telco industry, all of us, not just one of us, into sort of the modern era, if I can be that bold. And that means you really need to do a lot of transformation. You need to get involved in communities. I think that, the coin of the realm is contributing code. Your opinions are nice, and I love your requirements, and I love your use cases too, but if you're not willing to pony up some code that does that, I got other things I need to be doing. And of course, I'm the one to speak, right? You know how many lines I've contributed. And in this case, there's really, we got to get beyond, in the past there's been, I think, some sort of head-butting around who should be the lead in the open source environment, especially around controllers. And what I've learned is that there's so many places that a, quote, controller is used. If you want to talk about controllers, I got a disk controller, I got a graphics controller. we don't need religion in that space. What we need is openness and ability to use what makes sense for the task at hand. And ONF folks are helpful. From a telco perspective, we know a lot about protocols and how things are done in telco. Not so much about the bleeding edge cloud technologies and what's coming out in the software world. And ONF has been a kind of a good marriage for us to kind of get that, I would think, cloud thinking and approach to software architecture and design to mash up with all of the folks who understand telco efforts from their realm. And then, we're really looking for people to collaborate across projects, across areas. Crano has been brought into the activity at ONF, and I'd love to see, and ORAN and ONF are going to play nice together. So it's a lot of places to touch and avoid cliques and clubs. But I think that by working together, all of us get there faster. It's sort of a problem where you have some effort you put into the community, but because it's a community thing, everyone else is putting in that similar effort, and the result is way more than what you have spent to get there. So with that, thank you very much, and I appreciate it.